This email was the beginning of everything that I'll be talking about in this video. About 4 months after applying for a PhD position at the Urban Center for Doctorate Training, I had almost given up on my chances to be accepted for a research position which included work on fundamental studies, experimental measurements, computational fluid dynamics simulations, all in the same projects in the field of energy and buildings. My journey began 10 years ago when I was completing my bachelor's degree in mechanical engineering at the University of Gilan, a university north of Iran, where the study of energy, environmental and climate change impact of heating, cooling, ventilation and air conditioning in the built environment caught my attention and really interested me. As a result of this, as part of my master's degree in energy conversion, I undertook a detailed study of indoor thermal comfort using computational fluid dynamics. The result of this study have been published in high-ranking international journal last year. The following days after Dr. Paul O'Sullivan's initial email, I was both stressed and excited to have this opportunity. Hopefully, he would accept my application for this PhD scholarship founded by Science Foundation Ireland under the supervision of Dr. Paul O'Sullivan at Cork Institute of Technology and Professor Malcolm Cook at Loughborough University. After a long and anxious trip from Iran to Ireland, I met Dr. O'Sullivan at CIT for the first time 8 months ago. After much brainstorming and many discussions about the project, I started to review studies related to passively cooling buildings in a sustainable way using natural ventilation. It took 6 months to review an acceptable number of studies and prepare my PhD proposal on improving the performance of single-sided natural ventilation using airflow guiding components, such as architectural louvers, which are becoming increasingly popular among architects. In single-sided natural ventilation, we have an occupied indoor environment with opening or openings at only one side of enclosed space. This is least efficient yet most common scenario in natural ventilation in buildings. For this reason, the investigation of the flow field in this type of natural ventilation at the first stage and enhancement of the flow rate using airflow guiding components at the next stage is of major significance and has a high potential for impact. This evaluation will be done by simulating the flow field numerically using CFD methods to have more details of flow characteristics. The CFD modeling will be done using software such as ANSYS Fluent. Drawing the 3D model of the geometry and its environment, meshing the computational domain, and solving the Navier-Stokes and energy equations by selecting suitable turbulent model is the planned process for undertaking the CFD part of the research. To validate the results of numerical simulations, we need to compare them with measured laboratory data, which will be taken from CIT Energy Lab. For example, pressure gradient and velocity at the opening, and air change rate using tracer gas decay method, and so on. Finally, it is important to evaluate available empirical models to estimate natural ventilation rate provided by other scientists for the case of single-sided natural ventilation with louvers at the opening. Simplified prediction techniques such as empirical models are useful for engineers and designers to have good estimation of natural ventilation application. All these steps should be done to give us a better understanding of flow field and let us improve the design and efficiency of louvers as airflow guiding components at the opening. We are also very excited about the prospect of engaging with industry as part of this project. Early collaboration with industry will ensure that we are addressing the most pressing and important challenges faced by companies developing products that enhance airflow into the buildings. As a person who has experience of working in industry, I believe one of the weaknesses of PhD or research projects is the lack of industrial relevance in their findings. If you're interested in our project, please do not hesitate to contact us.